In this lesson, we're going to examine the relationships of lines and angles. So the objective for this lesson is to identify lines that are parallel, perpendicular, and skew, and then to also find angles that are formed by two lines and a transversal. Here's a list of important vocabulary words and phrases for this lesson. And we'll start the lesson by looking at this diagram and defining some of the terms that are in our vocabulary list. Starting with the first one, which is parallel lines. Parallel lines are coplanar and do not intersect. And as a reminder, if you've forgotten, coplanar means that they exist in the same plane. Our next term is perpendicular lines. Perpendicular lines intersect and create or are at 90-degree angles. We also have skew lines, which are not coplanar. They're also not parallel, and they do not intersect. So there's a lot of nots in that definition for skew lines. And the last one for this diagram is parallel planes, and these are planes that do not intersect. So let's go back and let's look at some examples of these. Looking at our diagram here on the right, an example of parallel lines might be AB and EF. And the way we signify parallel lines in a diagram is that we use these arrows, okay? Now I actually have a second set of parallel lines, EG and FH, and I also signify that they're parallel, but they're parallel to each other and not to my first two lines. So I'm going to use two arrows to notate that. If we look at perpendicular lines, an example of that here is going to be EG and GH. If you look at those lines, you'll see where they come together. We've actually made a note here with this red square, which signifies that we have a 90-degree angle. And that's one of the criteria for a perpendicular line. If I want to find skew lines, these are going to be lines such as AB here at the top and EG here at the side. Okay? Now, line AB exists in this plane, right? Plane ABF, okay? Whereas EG exists on this plane that's at the front. Okay, now those planes do intersect, but the lines do not. Okay, these lines here, EG and AB, will never touch, okay, in a 3D shape. And going on to an example of parallel planes, let's go back and just look at the top two, right? Sorry, the top and the bottom. Plane ABF is parallel to plane CDH. Okay, this top plane right here, mark it in here, is parallel to this plane at the bottom. All right, helpful hint. Segments, arrays that are parallel, perpendicular, skew if the lines that contain them are parallel, perpendicular, skew. Okay, so now remember, segments and rays are built from lines, and so if those lines that they're built from are parallel, perpendicular, or skew, the same is going to be true for those segments or rays. Let's take a look at an example to practice kind of our new knowledge from that diagram. So A, here I'm looking for a pair of parallel segments, okay, a pair of parallel line segments. So I'll give you an example of one, which would be LM and QR. LM is this line right here. QR is this line at the bottom. Okay, those are parallel segments. No, they're not the only parallel segments in this diagram. Oops. Okay, there are a number of parallel segments. In fact, things like SP would be parallel to QR. Okay, and so would this line here. I could also designate parallel lines from KP to MR, right, in this corner. Okay. If I want to find a pair of skew segments, an example of that might be line KN and line PQ. Okay, those lines were never going to intersect, and they actually exist on separate planes. Okay, plane here and the plane on top. So let's go and identify an example of a pair of perpendicular segments. So NS would be one part of the line for a perpendicular segment, and SP could be my other line. And I'll notate that with my right angle symbol. Okay, now again, like I said, in this diagram and in lots of diagrams, these are not the only parallel segments or skew segments or perpendicular segments. Okay, I'm just giving you an example of some. So if I want to find parallel planes, plane NMR, okay, now that plane is going to be this part at the front of these cards. Okay, I'll shade that in a little bit to try and notate it. So the other plane that's parallel to that is going to be this one here at the back, KLQ. Okay, is my other parallel plane. All right, you give it a shot this time. Hit pause, and I'll come back with the answers. Okay, so let's check it out. Now then, again, these are examples of answers. BF is parallel to EJ. BF and EJ, good. And again, look for these signifiers here, right? Parallel is what they indicate. Skew segments, BF and DE. Now, we don't have anything that signifies when we have skew segments. Okay, so it's not like you can look at the diagram and say, oh, there's a skew segment based on any sort of markings. Okay, pair of perpendicular segments, something you can look for there. Sometimes there might be a right angle symbol, okay, for BF and FJ. Now, that's not to say that you don't have a right angle here created by perpendicular lines, as well as back here and a number of other places on this diagram. And lastly, parallel planes could be FJH, this one at the bottom, and BCD here at the top. Okay. Moving on, okay, to another relationship of lines. And these are going to be angles or angle pairs that those lines create, and they're formed by a transversal. So let's talk about that. A transversal is a line that intersects two coplanar lines at different points. So an example of that, we'll just dig right in, is this line right here is the transversal. Okay, cutting across two or more lines. Okay, you could have lots of different lines up here. Okay, kind of like a parking lot. If you've seen a parking lot, that's a good example of a transversal. Corresponding angles. Okay, these are angles that are on the same side of the transversal. Okay, they exist on the same side. So a corresponding angle might be angle 1 here and angle 5. Right? They're on the same side and in the same relative to position. So if I look at this group of angles right here and this grouping here, notice that angle 1 is in the upper left, angle 5 is also in the upper left. That's one way where you can one way you can use to identify corresponding angles. Alternate interior angles. Okay, that's a kind of self-explanatory, but let's make sure we go over it. So alternate means on opposite sides. So it's going to be on opposite sides of the transversal. And interior. Okay, well, opposite sides of the transversal and interior. Okay, and we're not looking for linear pairs. Okay, like 5 and 6, that's a linear pair, but they're not alternate interior angles. Okay, we also need to alternate not just across the transversal, but across from groups. So again, I'm going to look at this grouping of angles here and this one here. And if I'm looking for alternate interior, an example of that would be 3 and 6. Okay, they're on opposite sides and they're in opposite groups, as well as being on the interior. Okay. Alternate exterior angles, very similar. Okay, but now we're looking for angles that are on the outside and alternate or on opposite sides of both the transversal and in the group of angles. So angle 1 and angle 8 would be alternate exterior. Okay, they're on opposite sides of the transversal and opposite groups. And the last one here, same side interior. Okay, so same side interior, they're consecutive. Okay, so we're looking only at the interior and on the same side. So 3 and 5 would be one example of same side interior angles. Okay, so there's a lot of vocabulary terms to know in this lesson. This is a good time to talk to you about using flashcards. I highly encourage you to make yourselves flashcards to review some of these terms and this terminology, just as if you were learning new words in a language arts class or something. Okay, it's a good study tool. Okay, so here we're going to practice classifying pairs of angles. So we're going to give an example, okay, just one example. Sometimes there's more than one, but I'm looking for corresponding angles. So one example of that would be 1 and 5, okay? They are in different groups, but in the same general location. Alternate interior angles. Opposite sides and opposite groups. Alternate exterior, opposite sides and opposite groups, and same side interior. Okay, here's some for you to try on your own. See what you come up with. Go ahead and pause the video and we'll be back. Okay. Let's just check out and see how you did. So we're just giving examples, okay? And an example for corresponding angles would be 1 and 3. Okay. Example of alternate interior angles, angle 2 and 7. An example of alternate exterior angles is 1 and 8. And same side interior, you could use 2 and 3. So I know this is going to take some practice to get used to, plus there's a lot of vocabulary. So when we come to class, we'll try and do some examples on the board to practice this. Make sure you're asking me questions when you get confused so I can clear that up for you guys. Okay, so now we're going to look at one that's a little bit, it's still a transversal, but it's a little bit different. Okay. So here, in this example, we're going to identify the transversal and then classify the angle pairs. So the tricky part about this is all 3 lines are crossing 2 other lines. Okay, so we're going to have to base it on the angles. So if I'm looking at angle 1 and angle 3, okay, angle 1 and angle 3 here. Okay, if that's the 2 angles, right? That's my relationship. And this kind of, I'm going to take you back. This is where this helpful hint is important back here. So if you're trying to figure out which line is the transversal based on the angle pair that you're given, look for the line that connects the vertices. Okay, so now let's go back to this diagram. So if these are my two angles, 1 and 3, okay, which line connects the vertices? Okay, is it line L, M, or N? Well, I notice these vertices exist on this one line L here. That's going to be my transversal. So transversal L, and now I need to classify my angle pair. Well, looks to me like they're on the same side, but they're in different groups. So for me, that indicates corresponding angles. Okay, and I'm going to write it in shorthand here, CORR, and then the angle symbol S. Some people, and I'm okay with this, if you use CA for corresponding angles. Let's try the next one. We're looking at angle 2. Whoa, don't want to give you that yet, sorry. So we're looking at angle 2 and 6 here. And again, we're going to connect the vertices, okay, and which you already saw the answer to that part, which is line N for the transversal. Now the relationship between these is going to be alternate, because it's on opposite sides, and they're both in the interior of this set of angles, this set of angles. Okay, so it's going to be alternate interior. And if you want to write that a little shorter, you can write it as AIA, alternate interior angles. And the last set, 4 and 6. The transversal will be M, and the relationship will be alternate exterior, because they're on the outside, alternate exterior angles. So you guys give it a shot. Pause the video and try and do the same thing for angles 2 and 5 in this diagram. Okay, let's see how you did. So angle 2 and 5, remember we're going to connect the vertices, figure out which line connects them. Looks like line N. And the angles are same side interior, right? They're on the same side and on the interior of these two lines, okay, on the inside. Okay, good job. And again, keep those questions coming so we can make sure we clarify all the stuff you're struggling on.